the diameter. There you go. That's all parametrically linked. What's up, YouTube? If you're a structural engineer and you want to start using Python and other scripting tools in your day-to-day job, this video is for you. I'm going to show you how we can use Python to do typical things like create drawing grids or cross-sectional views of reinforced concrete columns or piles. And the cool thing about this is you can do this without any experience in Python. I'm going to show you how we use AI. Controversial opinion here, but I actually think learning Python is a complete waste of time, and we can invest our time in other things with a high return on investment. So hang around. So firstly, we're going to open up Rhino. I've already got it open here, but if you don't know what it looks like, that's it there, Rhino, and it comes in here. You'll often hear people talk about Rhino and Grasshopper interchangeably. When I started learning about it, I didn't really understand why until I started using it. Grasshopper is within Rhino, so that's why people use it all the time. It's not a separate software, but it is sort of a separate tool. So within Rhino, you hit this green ball to open up Grasshopper. Okay, so this is what Grasshopper looks like, and if you're wondering what the difference between the two is, Grasshopper is sort of where the coding happens and the parametric and the visual programming, and Rhino is sort of the viewer for it. You can create geometry in Rhino, but if we're talking about coding, we more talk about Grasshopper. So I said before, you don't need to learn Python, and that's because AI can do it for us. If you're in Grasshopper, I'd suggest getting this package called Kia. You won't have it as soon as you download Rhino and Grasshopper. So to get it, you need to come into the package manager here. You search for Kia, and this comes up. It's Kia itself is free to use. You come in here, you search Kia, open it up, and it's a bit like talking to ChatGPT, but it's more around specific for creating code. So one thing that we use day to day as structural engineers, we create grids in our drawings, in our analysis models. So I'm going to ask it to create a 2D, create a grid in the XY plane. So there you go, there's our grids that you can see here in the XY plane. I can change how many are in the Y direction. I can change how many in the X direction. And we've got the Y spacing and the X spacing over here. And yeah, that was created in C#, I believe. We can open up if we want to pop the bonnet and see the code that's driving this. It's pretty simple, as we'd expect for a grid, but I know if I was to do that myself, if you got experience in coding too, you get bugs, and you won't be able to produce it as fast as the AI can do it. So that's why my opinion now, and correct me, if you disagree, drop it in the comment and tell me why it's important to learn to code instead of just using AI to do the coding for you. This here is the code that the AI has created, that Kia has created. So we might want to modify it. That's okay. So this is just sort of like, some grids in plan, but I might go, Kia, please always speak politely to your AI scripters. Please add the Z axis to this grid. So if you're doing analysis models and 3D geometry, you need 3 axes. So we're just gonna change the scripting here to add the Z axis. Let's see what that looks like over here. You can see the scripts just updated based on what I've prompted Kia. And there you go there. We've added the Z axes, and yeah, we've got sort of like a axes in We can go and add labels if we wanted. It's all dynamically linked. And we can put that into our analysis models or sort of our tools that we use to, Revit, AutoCAD to create design documentation. Okay, let's do a reinforced concrete column or pile as another example. So I'm going to come in here and grab Kia and ask it, create a reinforced concrete column in section view. Inputs, I'm going to let it know it's circular. Inputs include diameter, vertical rebar size, shear lig size, and concrete cover. So we give it that as a prompt. Kia thinks for a little bit, and it's going to create the C# code or Python or whatever you prompt it. I think it is a default. This is choosing C#, but we can tell it whatever we want. So diameters, let's go 400 to 4,000, which is a relatively big column. We can see the outside of our column here. Rebar size, let's just say the N24s. Lig size, let's start with 12s. You can obviously edit all of this later. And concrete cover. Let's go, let's use a number slide again. And go 0 to 100. So as the cover increases, obviously the shear ligs, and as we'd expect, go inside. So it knows what concrete cover is, the diameter. There you go. That's all parametrically linked. But I'm coming in here and I can see that it's not really showing the shear lig correctly, because in plan I need to see the inside and the outside of the lig. So that's one thing. I'm just going to come in and prompt Kia. Say there should be 2 lines, the inner circle and outer circle, showing the shear lig. Okay, so that's better. It's got the shear lig there, but it is overlapping our vertical reinforcement. So I'm going to come in and prompt the inner line of the shear is overlapping the vertical reinforcement. Let's see if that corrects it. There you go. The shear lig there is on the outside, as we'd expect, of the vertical reinforcement, confining it together. We can change our concrete cover. You could do other things and, specify the number of vertical reinforcement bars. That's something we haven't done. And then you've got the diameter there. It's all parametric now. And this is something that we can use. We can export this Rhino file and we can link it to, say, our AutoCAD, or if it's Revit, whatever tool that we're using to create our design documentation. So that's how you can pretty much use Python and C# and other scripting tools with no prior knowledge for your day-to-day task as a structural engineer. If you've got any questions or you want to see something else, drop it in the comments. If you disagreed with anything, let me know. I'm keen to hear why. I'll get back to you. And if you like this, make sure you give it a like and subscribe.